Hi students, in this class I'm going to teach you guys how to do differences analysis, and specifically the first type of difference analysis we're going to do is an independent samples t-test. And as you know from class, independent sample t-tests are used to compare two subgroups in your sample on one specific question. So let's say, for example, in this craft beer data set, we want to see if men versus women, so we will be looking at the variable gender as the grouping variable, if men versus women differ in a certain metric scaled question, so in their average answer to a metric scaled question. Let's say, for example, we want to know how men and women differ on their lifestyle regarding being craft beer enthusiasts. Maybe men or maybe women on average think they are more like enthusiastic about craft beer. So let's test for that. First thing we will need to know later on in the analysis is which code we gave to males versus females. Because as you know, sometimes you can do 0, 1 for male, female. In this case, we used the coding 1, 2, and then 3 for other or refuse. So we will be keeping that in mind when we run our analysis. Okay. What we do is we go to Analyze. You click Analyze. You click Compare Means, because what we're doing is comparing means, obviously. We want to compare the mean or the average of men versus women on craft beer enthusiasm. And we go to Independent Samples t-test. When you click Independent Samples t-test, this window opens up. And you can make this larger if you want to. As you can see, actually, what I've done before is still in the memory of SPSS. It says lifestyle, I consider myself a craft beer enthusiast. This is this variable right here that we obtained from our list of variables. Lifestyle, I consider myself a craft beer enthusiast. Now this is a metric scaled variable, which means we can use it as the test variable. So we click that in. I mean, it was already in, so. Here we have grouping variable. Now, obviously, this is going to be blank for you guys. So we search for gender on the left side. We find gender, we click it in. And once it's clicked in, you see these two question marks. This means that we still have to define our groups. So we click define groups and we type in 1, 2. Now, of course, if we would have used the coding 0, 1, that would, of course, always have to correspond to whatever code we used in our questionnaire. Now, since we used 1, 2, in this case, we use 1, 2 here as well. Remember, here we used 1 for male, 2 for female. So 1, 2 corresponds to male, female. We, in this case, in this analysis, only compare two groups, males and females. We exclude people who clicked number 3, which was refuse or other. We omit these from the analysis. So we only look at males and females, or people who identify as male or female. We hit continue, and now this is exactly what we're going to do. An independent samples t-test for gender, looking at to what extent they consider themselves craft beer enthusiasts. We hit OK, and this is the output we get. So let me scroll a little bit to the right and make it a little larger. Actually, we don't need that too much, but in your output for the independent samples t-test, you have two tables. One table summarizing the group statistics, one table showing your independent samples t-tests. So let's start with the group statistics. So what you have in this table here is for the variable lifestyle, I consider myself a craft beer enthusiast. You see, first of all, how many males answered this question and how many females answered this question. Cool, we have 77 males, 58 females. We also see the average on this question, and it was a 5-point scale. See, for males, the average on this enthusiasm question was 3.4. For females, it was 2.84. We also see the standard deviation for each. So this just summarizes our group statistics, our sample statistics. Now, more interestingly, if we want to know whether the difference between males' average and females' average is actually significant, we look down here in the independent samples t-test. We look at significance two-tailed. The significance value is 0.015. Okay, so this is smaller than 0.05. which means there is very little support for the null hypothesis. And as you know, the null hypothesis always says there is no difference. But since there is very little support for that idea of the null hypothesis, we can actually say that the alternative hypothesis is true. In other words, yes, there is a significant difference between males and females' self-indicated or self-reported enthusiasm for craft beer. Now, in class, you probably remembered we talked about this Levine's test for equality of variances. So what that Levine's test does, it is some sort of like test within a test. It's a little subcomponent of the independent samples t-test, which shows you which line you should be looking at. The Levine's test for equality of variances has its own separate significance value. So it comes with its own significance value. If this significance value is larger than 0.05, that means the variances can be assumed to be equal. Remember, your Levine's tests for the equality of variances. So if that's the case, if this value here is larger than 0.05, which it is, we look at the first row of variances assumed equal. Now, if this value would have been smaller than 0.05, which it is not, but if it would have been, then we would have looked at the row of equal variances not assumed. In other words, there would be a difference between the variances of our two groups, in which case we would have looked at the bottom row. In this case, we look at the top row because this value is larger than 0.05. Larger than 0.05 here means we interpret the first row. Now, of course, it wouldn't have made a difference because these happen to be the same, but that is not always the case. So anyway, we know now, based on the independent samples t-test, that there is a significant difference between male and females' craft beer enthusiasm, or at least self-reported craft beer enthusiasm. Cool. Now, if you want, just for clarity, we'll go a little quicker and do a second analysis, same, an independent samples t-test on different variables, and go a little faster. So just to remind you, for an independent sample t-test, you go to Analyze, Compare Means, Independent Samples t-tests. Now, we want to use a different test variable. Let's say we want to, again, see if there's a difference between males and females, but this time not on craft beer enthusiasm, but on the subjective knowledge index that we created in an earlier video. So we click Subjective Knowledge Index, which is also a metric scaled variable. We click it in there, and we want to see if there's a difference between males and females' subjective knowledge about craft beer. We hit OK, and here's our output. We see that, again, the average for males is 3.67. The average for females is 3.06. With the naked eye, we would say there's a difference, but let's look at whether there actually is a significant difference. This is where we look. Significance two-tailed. The reason why we look at the first row is because for our Levine's test, the significance value of the Levine's test is larger than 0.05. So we look at the first row and we interpret this value. 0.000 means there is a significant difference between our male and female subjective knowledge about craft beer. Males actually think they know more about craft beer than females do. So the subjective knowledge of males is higher. We could have also come to that same conclusion by interpreting the t-value. So as you know, the t-value is actually nothing more than the same as a z-score that you would calculate if you were to use a formula. Now in this class, we're not going to rely on formulas. We're actually using SPSS, and SPSS reports it as a t. So what this t-value shows you is the very same thing, except that the benchmark is different. So here we use the benchmark 1.96. Since this t-value, this t-score, is 4.05, which is larger than 1.96, we know that we have to reject the null hypothesis and accept the alternative hypothesis, which states that there is a significant difference between our two values that we are comparing. So this confirms what the significance value has also taught us. Okay, so that's it for independent samples t-test.